In this video, we're going to look at plane mirrors, that is flat mirrors. We're going to look at their properties, how they behave, and we're going to look at the images formed in them. So let's have a look at images. Here is a board writer, which I will call the object. And this is placed exactly 15 units from the mirror. Here is a second board writer that is going to be placed also exactly 15 units, but this time behind the mirror. Now you can see that the image of the first board writer, that's this one here, formed in the mirror, seems to coincide with the locating board writer, I'll call it, behind the mirror. In fact it does, and in fact it stays with it no matter where I put the camera. And therefore we can say that the object and the image are both the same distance from the mirror, one in front, one behind. So to summarize that, the image formed by a plane mirror is the same distance behind the mirror as the object is in front of it. But you might also notice something else here. The numbers that you can see reflected in the plane mirror are not up the right way. And we need to have a look at that now. Now this is a further example of this reversal. You can see that the printing on the section of the Radio Times that is the object there is the right way round. But when the page is reflected in the mirror, it is reversed. Now I know you're looking at the back of the sheet, but I will prove to you that in fact the printing on the other side is in fact the correct way round, but on reflection in the mirror it's reversed. You can see what looked fine before is now reversed by reflection in the mirror, and if we turn it right round again you can see that every time we view it by reflection the printing is reversed. This is called lateral inversion. Here's another way of looking at lateral inversion. Imagine you were standing in front of the pig and the sheep looking at them. Then you would see the pig on your left and the sheep on the right. But now if you look at their reflection in the mirror, the sheep is on the left and the pig is on the right. So lateral inversion again. We're now going to have a look at what happens when you have not just one mirror but two, and when these two mirrors are inclined at an angle to each other. Now to start with, the angle is exactly 90 degrees. And you can see you've actually got the original pig and sheep at the bottom of the picture, but we've got three images this time, not just one. Well, how are these formed? Well, the ones on the left and right of the shot are formed by the reflection in one of the two plane mirrors, but the one in the center is formed by a reflection of the image in one mirror in the other mirror. So a reflection of a reflection. And you'll notice that this image is not laterally inverted. Well, I'm now going to try altering the angle. This is really quite difficult, so it may be a bit wobbly. To start with, I will reduce the angle. And you can see what happens. You get lots and lots of pigs and sheep. So reducing the angle means more images. And if I now increase the angle, we'll go through the 90-degree point, which is somewhere around there, and we then see we lose the central one, and eventually you may be able to see what's going to happen. If I could get the two mirrors at exactly 180 degrees to each other, we would get back to the situation with just a single mirror, which is just one image. There we are, exactly one image. So reduce it again, and we go back to our case where we have the three images and the one in the center is not laterally inversed. So to summarize, changing the angle between the two mirrors changes the number of images. The smaller the angle, the more images we get, and the bigger the angle, the fewer images we get.